Okay, first of all, thank you for having me on the program. Um, so this is a joint paper with Stephen and Andros Kourtellos, who is a former student of mine. She's now a postdoc here at the University of Cyprus. In fact, this is a truly intergenerational paper in terms of authors, being also a student of Stephen. So in this paper, we studied the intergenerational transmission of income by focusing on the role of trajectories of exposures during childhood and young adulthood using PSID data. Our analysis shifts the focus from a single number that summarizes the intergenerational mobility to a curve that captures the intergenerational trajectory over the course of over the life course of an individual. And in doing so, what we do is that we employ a functional data analysis approach that allows us to construct these intergenerational trajectories, these curves. So why do we care about intergenerational mobility? We care about intergenerational mobility because for several reasons, but my favorite reason is that it provides, we care about mobility because it provides insights to quality of opportunity among individuals. There is also a connection between income inequality and intergenerational mobility, as we have seen several times during this workshop. And we all know the Great Gatsby curve, okay? But I would like to make here a point that the Great Gatsby curve does not necessarily need to be linear. It can also be non-linear. In some other work, what I show is that actually the Gatsby curve can also be what the Korak and co-authors have shown. It's actually applies only to higher levels of inequality. That's the first point I would like to make. And the second point is that, as Dorloff and Shashatri argued, is that the Great Gatsby curve actually is an equilibrium outcome where inequality is a causal factor of immobility. And the important point here is that these current levels of higher cross-sectional inequality might have long-run implications beyond the current generation. And of course, this is very especially worrisome given the rising trends in economic inequality in many economies in the world. So I don't need to elaborate on this, especially this audience, that, okay, the standard empirical approach has focused on the IG, okay, on the linear IG model. This model is suggested, as we know, from the classical theory of family income or investment models due to the seminal work of Becker and Thoms. And one key aspect in the literature is in the implementation of the IG model is the measurement of permanent income, which is latent. So the standard empirical practice, we know, measures permanent income as an average over several years. However, there is no a priori reason to believe that a simple average of observed income is a sufficient statistic for permanent income for several reasons. In fact, I would like to argue that this notion of permanent income, as it was conceptualized by Friedman, was not statistical, but rather behavior. So the permanent income, the permanent component of income can be viewed as the effect of the factors that the individual perceives as the determinants of her lifetime, non-human and human worth, including personal attributes, family characteristics, location, and other things. What I mean location, I mean schools, economic activity, social capital, etc. Of course, we know also from the literature, that has been developed over the last 20 years by Heckman and co-authors, that the timing of human capital investments and dynamic complementary investments challenges these IGE. Also, the dynamic complementarity can also interact with the timing of borrowing constraints, as argued by Kokat and Lochner. And also, there are good reasons why prenatal and early childhood environments matter, and we need to account for them. Surprisingly, though, much of the literature has focused on the linear model. And as pointed out yesterday, a notable exception is a paper by Salvanes and co-authors who examined the role of the timing of parental income during their childhood years using admin data from Norway. What do we do in this paper? So in this paper, we shift our focus from a single number, the IgE, that summarizes the mobility, to a curve that captures the intergenerational trajectory over the life course of an individual using functional data analysis. We examine the role of the timing of parental income during childhood and young adulthood years using annual or biannual data from the PSID. In this presentation, we will only focus on biannual. And we also investigate the heterogeneity in the intergenerational trajectories of income due to the socioeconomic status and structure of the family. One of the things that also plan to do in this paper is that we'd like to reverse the question. Namely, we would like to predict the set of trajectories that give rise to the observed child outcome. So, in particular, we ask the following questions. What sets of trajectories make success of children relatively likely versus unlikely? What do trajectories that produce similar likelihoods have in common? And how do these sets of successful and unsuccessful trajectories differ? So, let me talk a little bit about the data before I describe the methodology. Okay, so we're focusing on PSID data, and child's income is measured by the labor income as a 3-year average centered at the age of 35. Parents' income is measured by the taxable income of all earners in the family when the child is at some age, starting from age 1 all the way to 24. At this point, I would like to actually point out that there is a trade-off in our data between centering the parents' age later on. So if we follow Bash's paper and center at age 40, we don't have many observations. So we have to there is a trade-off between in the way that we set up our data set. So yes, there are concerns about the life cycle bias, but because PSID data does not have many observations that allow us to consider data parents when they have children from age 1 all the way to 24, we have to allow young parents as around the age of 30. We compute the logarithm of both parents' income and child's average income. And this is how basically the profile of parental income is for the age of the child. We also consider father's educational attainment measured by years of completed education. For family structure, we consider intact and non-intact families. An intact family is defined as a family for which both parents stayed together for the entire childhood of the offspring until the age of 18, or until the age of, or until the offspring left home, whichever occurs earlier. A non-intact family is then defined as all the other types of families, including single-parent families. We're also looking to also use child schooling as an outcome variable. So in this case, we measure the child's educational attainment is measured by the complete years of education for individuals that are at least 25 years old. So I don't have to explain you this. So this is a linear IG model. And of course, as we discussed, a major limitation of this model is that it ignores the parental influence during the ages of exposure of children and young adults. So one would say, okay, how about a naive generalization of the IG model, such as equation 2? Okay, suppose we take equation 2, that, as you can see, we have t parameters to estimate. And let's make the following normalization, that we sum the parameter, all the coefficients sum up to 1. And then we can rewrite the previous model as the sum let me just, as the sum of two components. The first has to do with the usual average. Okay, this is the usual proxy of the permanent income, which is the simple average, plus the sum of average, plus all the future, the sum of average, this is the future higher order differences. Okay, so this sum captures all these future higher order differences. So this implies that the traditional linear IG, basically, which only conditions on the average, on the proxy of permanent income, will result in an omitted variable bias when these higher order differences, okay, are going to be correlated with the error, okay? So that actually can give us a testing strategy. So we can view actually these higher order differences as potential instrumental variables, and we can construct a Hausman type test to test actually whether there is the specification, or the misspecification of this IG model. So we can estimate 3, okay, using this, actually this can be viewed as a control function approach. And we test the hypothesis that delta equals 0. And of course, as you can see here, for any values of ages above 8, we reject this null, which suggests that the IG model is unspecified. Of course, there is an issue here with the optimality of instruments, but I'm going to ignore that for now. So, in this paper, what we do actually is we're gonna use a more general approach, okay, rather than naive approach. And the reason that we don't want to use that naive approach is because it suffers from incidental parameters and it estimates individual parameters, okay? It does not estimate curves. So what we propose is to estimate equation 4, which is a functional regression, which will allow us to estimate the intergenerational trajectories as curves, okay? So basically, the idea here is that our approach treats the observations as snapshots of an underlying latent curve, and the annual income data are treated as discrete signals of a latent income process, okay? And as I said, we shift the interest from a scalar to a curve here. So basically this problem, it turns out to be an infinite dimensional problem, okay? And as we will see, we will need some kind of regularization or smoothing. So this model can be expressed in terms of the inner product in Euclidean space, as in equation 5, okay? And to see this, we follow the standard approach and we expand both the permanent income, we expand both the income variable, okay, and the coefficient function in the B-spline basis, as in these equations, and the model becomes can be written as in equation 6. So clearly, this is an infinite. This is to proceed. We need some kind of a regularization, and as we will see, we need to choose a finite to approximate those infinite sums. But before doing that, I need to point out that we use B-spline basis because it's flexible and also allows us. It allows us to. It's a very useful basis for computational speed and stability. Like we could also use Fourier bases, but those bases are more appropriate for the cases of when you have like periodic data. So that's why we would like to use B-spline basis in our case. Smoothing of the beta coefficients reduces the collinearity in the regression and makes the estimates more efficient and more interpretable. Smoothing of the actual income variable reduces measurement error and that allows for sparse and irregular data. So the regularization step requires truncating of the series at some finite order that should increase with the sample size. And we can rewrite the estimation, we can estimate this model by least squares using this standard criteria. And what we do is that we choose the number of basis function using a generalized cross-validation criteria. In terms of inference, we use bootstrap, we employ bootstrap confidence intervals using 1000 replications. Okay, I'm going to start with some I'm going to show you, I'm going to focus on the long sample, meaning that this is a sample that includes ages from individuals from ages 1 all the way to 24. And in this, here we show the left picture shows child's income, the dependent variable child's income, while the right one is child schooling. And as we can see is that in both cases, so we see the black line is the intergenerational the curve that we estimate, and we also have the superimposed bootstrap confidence intervals. The green line, okay, is what you would get if you estimated a linear IG. Okay, that's a constant line that you would get if you estimated the standard model. So what we see is that parents' income is more productive in the early and late childhood. Okay, so this finding is consistent with Carniero or paper, who find that parents' income in the early and late childhood is more important for the offspring's educational outcome than parents' income in the middle years. We also find that they also document the importance, as you can see here, the importance of the late childhood, the importance of the young adulthood, as you can see from this uptick in the late adulthood. Actually, more insights can be obtained if we look into the stock of income. And there are good reasons why we like to do that. Parents' annual income determines, as we know, the human capital investments at any given age, as argued by Bernard Lequin. And we should all expect that offspring's income is determined by the trajectory of the cumulative income of parents. The other nice thing about the cumulative income is that it actually becomes continuous in time. So if the lifetime of human capital and wealth of the parents only matter, then only the stock of the last period matters. And in this case, we have to focus on partial effects, okay? So we compute this derivative. So if we plot the partial effects, we see actually how these trajectories vary over the lifetime of the individual. And we see the importance of these investments in the late adulthood. Additionally, we investigate heterogeneity. As previous speakers have argued, there are good reasons why we should care about heterogeneity. So I just list a few here. The presence of intergenerational credit constraints, okay, is one reason why we should care about heterogeneity. These credit constraints might have to do with the inability of parents to borrow against the future income of offspring, like the Lowry or Galorens-Zaira models, or they may have to do with endogenous credit constraints, like the constraints suggested by Hay and Heckman. Or we might have the presence of neighborhood effects that, as argued by Benabou or Dorlov, these neighborhood effects actually imply non-linearities and heterogeneity in the intergenerational dynamics. So what we do here is something very simple, okay? So basically we look into some sample intergenerational functional regressions. This is what we do basically, okay? Where these some samples are pre-specified, okay, according to according to some quartiles or quintiles or quartiles of income, or some other or some family type, as we will see. So first, we look into the heterogeneity with respect to parental income. And what we find, actually, we find a lot of heterogeneity, especially with respect to the poor, okay, which exhibit quite substantial variation, which actually can see clearly when we look into the partial effects. Here we have the first four the trajectories that are clustered by the 4 quartiles based on the average income throughout the lifetime of the parents. So as you can see, the very poor ones, okay, with the red trajectory, okay, not only they exhibit the lowest in level partial effects, but also those partial effects decline, become negative in the late adulthood, okay? While all the other quartiles, okay, in the late adulthood, especially the third quartile, exhibits very strong positive effects. So this is a stark difference.
Andros, can I ask a question?
Yeah.
So when you say quartiles, so that is defined by the sum of parental income over the entire childhood / young adulthood.
Yes, yes.
So I guess that if parents' income increase with age, so they earn more when I was 24 than when I was 2, then the partition of parents' income in quartiles is going to reflect mainly what happens later in childhood. So basically what you'll be splitting the sample on there is who have a high income in children's young adulthood. So could that drive some of the heterogeneity in the results? So that was one question. And then the second question is in terms of the overall uptick. So, and again, I may just get it wrong, so the best predictor of what I do today was what I did yesterday. So you have that you gradually, as you get closer and closer to young adulthood here with parents' income, you get closer and closer to when you measure children's income, basically. So if there are any shared factors in that, then could that just explain why, I mean, the most recent, the young adulthood estimates predicts children's income more?
It could, your last point. But on your first point, let me just show you something that we do that might clarify your question. So here, actually, we look into the timing of family disadvantage. So we cluster the clustering now is based, we don't use the whole parental income, okay, but we cluster according to what we call early shocks or late shocks. So by early shocks, we take the averages of the parents during the early years, and we take the averages. So the clustering is based on during the average income during the late adulthood of the child. So as you can see, for the very poor ones, okay, the time doesn't really play a role, okay, but it does play a role, okay, if you are talking about middle income people. So, and it plays both in levels, but also in the source of uptick, okay, for the late adulthood. We also investigate the heterogeneity with respect to father's education, and what we see is that basically the pictures that we saw in the beginning are driven basically by the high school graduates, and this is expected. Okay, so this subtle U shape that we obtained in the overall, or using the whole sample, is basically driven by the high school graduates. And again, we can see that from the partial effects. Finally, I would like to show you something that about the family type. So here we look into intact, not intact families, but we just now I'm going to just focus on not intact and compare the partial effects when the shock occurs during the early years of the child, and compare those trajectories against the trajectories for which the shock occurs late. And as we would expect, okay, when the shocks occur early, okay, there is both a difference in the level, but also in the uptick during the late adulthood. Okay, so
Professor, you have about five more minutes.
Okay, having the a shock very early on, this actually is makes a family very disadvantaged. So basically, we look also, we also condition of father's education, and the results still hold. We're also looking to the daughters and daughters and sons, and we find stronger actual effects for daughters. And we also consider a short sample, 1 to 18, and we have more observations, and the results are pretty much the same. Okay, some work in progress. We also we plan to look into this, to consider the heterogeneity more formally using functional mixture models that will allow us actually to investigate this heterogeneity of trajectories in a more formal way. We can also allow for a functional dependent variable using a functional linear regression, okay? In this case, we can also allow the child's income to be a function. And that can also generalize our analysis. So basically, we propose a novel way in this paper to measure intergenerational mobility of economic status. We find that the parental income in early and late childhood is important for the outcomes of children as adults. Parental investments for young adulthood can be at least as productive as the ones in early and late childhood. And we find that the socioeconomic background of the parents affect the trajectories of the offspring, and the timing of the parental income shocks play a key role in offspring's long-run outcomes. Early family shocks seem to affect more the parental investments, making them less productive. Okay, that's all. Thanks.
Okay, thanks a lot. Any subject questions?
So a comparison with this latest Carnero et al. Paper in latest JPE, they have it's a partially nonlinear model in which they use 3 periods to aggregate for permanent income. In the regressions, they leave the permanent income and 2 of the annuals. Mm-hmm. They drop 1. I'm thinking about why and how. My question to you is, do you keep the YP ever in your regressions and leave some of the trajectories, or you just use the trajectories?
I left the parental income, the average when I did the testing, okay, in those regressions, okay. When I test for the misspecification of the aging model, yes, I did it. When I estimate the functional linear regression, I didn't do that. But one could do that because potentially. And the reason that the Carneiro and Al did it is to be able to interpret, it helps in the interpretation of the results. That's why they did it.
I really like this way of bringing out, I think, the subtle issues about both the trajectories, but also what is the implicit notion of permanent income as a latent concept. As you know, some of the literature deals with it in terms of errors in variables. So you have this latent concept, every annual measure is a measurement error, as it were. In the interest of connectivity, when we were doing intergenerational, intragenerational mobility measures, which I talked about very briefly, this idea of how do you aggregate, how do you come up with permanent incomes was loomed large. And the linear averages were used. These weighted linear averages are implicit when you put the trajectory with the functional weights. You're letting the data determine what the permanent income is in a way. And if you're using log regressions, then you're basically using Cobb-Douglas averages as your permanent incomes. And I used hyperbolic means of these incomes as averages for permanent income. And one thing that makes a big difference is the number of periods you use. We found that was the big deal in terms in fact, in itself was a way of monitoring what's happening to mobility as you extended the period over which you aggregated. Here you're limited because you want matches, you want parent and child matches, and you're restricted to how many matches you can find. So it's tough.
I'm also limited by the PSID sample.
Yeah, no, very much.
Andros, let's say if the data are not an issue, would this single index model also work instead of using the functional data model? Let's think about the trajectory.
There is a way you could. There is a way to make these functional linear regression not parametric, actually.
Yeah, right.
Yes.
In some sense,
that's what you're referring to. Yes.
Yeah. So I think in some sense it's a single index model.
Yes, right? You could.
Okay.
So Andros, I have one comment. It seems to me you only measure the trajectory of the parent generation, but not the offspring generation. You still take average across all the years of observation you have for the offspring generation, which means that for those older offspring, so we have more years of data to estimate their permanent income. So will this cause some bias, or if the results will be associated with age of the respondents, simply because for older adults, we have more data. So we probably will cover those years in their 40s or 50s rather than only from their earlier careers.
I'm controlling for the ages of the parents and children as an additional regressors. But I guess if I understood your question correctly is that you also ask why we take the average of the child's income.
I mean, for some of the young adults in the offspring generation, we may not have a very good measure of their permanent income simply because they have not been in the survey.
True.
You know.
Yes.
So
So
this,
yes. So this is the limitation of the, I would say, the PSID data. If we wanted to actually look into the trajectories, we had to like make these compromises.
Mm.
Otherwise, our sample would be like very extremely small.
Mm-hmm.
Just actually a
Can I just make a point here, or go ahead? No.
sorry, no, just a comment actually back to Es's comment. I actually had a paper sort of looking at treating the permanent income as a measurement error problem. So that you now both your dependent variable and your independent variable can take into account that non-classical measurement error as simultaneously. So you don't necessarily have, if the interest is looking at the permanent income and permanent income, and our model sort of have a way to handle that simultaneously.
Yes, but this actually, this is, as I said in the end, one could use the functional linear regression to model the child's income as well as a function. Not so you don't have to take the average. We haven't done it yet. We plan to do it, and so that will take into account the measurement error problem.
Let me just make a point. Instead of sort of looking at sort of arbitrary indices, in some work that we've done here at the center, we've actually estimated life cycle models, but looking at intergenerational mobility in terms of value functions and accounting for the evaluation of future income streams, which prices out uncertainty and takes into account credit constraints. We have a series of results, and we find that that actually changes the nature of the estimates. We're using the Danish data, and I think it's a conceptually much cleaner approach, I think, than just adding up income and doing it in some arbitrary way. And it allows the economics of the model. So this allows us to also include consumption and labor supply decisions and the effect of uncertainty. So it includes things like the fact that the Danish welfare system causes income to be insured and is allowing us to give us some mechanism for showing how insurance is valued and affects the life of the child. And the thing that's interesting, though, that really gets into this question of timing of income is that as part of this process, we're able to estimate stochastic discount factors. And the stochastic discount factors allow us to price out what future income streams are. And that would include both earnings, and it would also include transfer income and other kinds of income that would be valued. And this essentially, I think, is a promising approach. We have a number of estimates, and we try those with other traditional approaches like this. It gives a very different light, sheds a very different light, I think, on the nature of the IGE, and gives us something that's actually very interpretable. This is something that Rasmus and I have talked about actually many years ago now in Bergen, but we now have estimates of it, and maybe at some future day, we'd be invited to present that at a conference, which would be good.